Welcome. In this video, we're going to take a look at how we can use the trig functions on the coordinate grid. In the last video, we looked at some definitions, and we are going to use those here. So for tangent, in this example, it tells us tangent is of an angle is negative 2/3. Which quadrants could the angle be in? At first, this might seem like an odd question, but if we draw a picture and we think about it, you'll see that there's actually two quadrants this can be in. Do you remember the definition for tangent of theta when we don't have a circle? When we don't have a triangle? Hopefully you do. It's y over x. So I need to find an angle where when I draw a circle, that the y value over the x value is negative 2/3. What to do with that negative sign? You actually need to put it either with the y, negative 2/3, or with the x. It can be in either place. So if it's with the y, this x is 3. We can think of this as the point 3, negative 2. We can think of this point as negative 3, 2. Now this is technically a ratio, so there would be other possibilities, but I'm just going to go with this one. So if we think about on a circle, if I go right 3 and down 2, I need to land on the coordinate grid. I'm picturing this as being 3, negative 2. I'm just kind of picturing this about like so. Or I could go left 3 and up 2. And again, I'm picturing about like so. So we can see negative 3, 2. In either case, this angle here, if we call this theta, that angle has a y over x of positive 2/3, positive 2 over negative 3. If I go this way, this angle theta has a, for the orange angle, we have y over x of negative 2/3. For the purple theta, we have y over x of 2 over negative 3. And in both cases, that gives me a tangent of negative 2/3. So which quadrants could this be in? If you remember in the previous video, we talked this is quadrant 1, 2, 3, and 4. And so quadrant 1 and quadrant 2 and quadrant 4. There is a second question here. If theta is in the second quadrant, find the other function values. So it's saying, let's focus in on the second quadrant here. So we're going to look at this. We need to find the other function values. So we need to find sine theta, which we said was y over r, cosine theta, which we said is x over r. We know tangent, we just found, it told us was negative 2/3. All right, what's the reciprocal of sine? Do you remember the reciprocal of sine? Hopefully you're thinking cosecant theta. Reciprocal of cosine is secant. Reciprocal of tangent is cotangent. So we know the reciprocal here is going to be negative 3/2. We've got an issue, though, for sine. We know y in this quadrant, but we don't know the radius. Hopefully you're remembering that if we zoom in, that this is 2, is my y value. This is negative 3, my x value. Hopefully you're seeing a radius here that's part of a right triangle, so we can do a Pythagorean theorem. So 2 squared plus, if you want to keep it negative, you can. It won't matter when we square it. And so this is going to end up with 4 plus 9. 13 is r squared. So r equals the square root of 13. So now we can just fill these in. Over here we have y is 2, because we're in the second quadrant, over the radius, the square root of 13. X we said was negative 3 over the square root of 13. And then we've got the reciprocals here. Cosecant is going to be square root of 13 over 2. Secant is the square root of 13 over negative 3. And again, if you want to rationalize the denominator, it's probably a good idea. 2 over the square root of 13, we're going to multiply by the square root of 13 over the square root of 13. So that's going to give us 2 square root of 13 over 13. And similar process here is going to give us negative 3 square root of 13 over 13. All right. Quick review on that. Really seeing this as coordinates, y over x. We could have two options, negative y over positive x or positive y over negative x. That gave us 2 points on our circle, one in the second quadrant, one in the fourth. Then to find the other 6 function values, we had to find the radius. And so we had to do Pythagorean Theorem here on this triangle. Remember, 2 was the y-coordinate, negative 3 was the x. That gave us the square root of 13. And then we just filled those in. Y over r, x over r, and so on. Found the reciprocals. We did rationalize here. That's helpful, but not necessary in my class. All right. Last part of this video and the last video in this section. So here we go. A unit circle. Probably if you've had a pre-calc class, you've heard of the unit circle. It has a center at 0, 0, and the radius is 1. Okay, so I would like to draw a unit circle. If you think about the xy axis, if I think of this as an xy axis, we need to find this circle with the center at 0, 0 and a radius of 1. That means when I draw it, the radius is going to be 1. You can see this is close to a radius of 1. This is a unit circle. Now, most of the time, we aren't interested in the rest of what's going on here. We're not interested in this. And so I'm going to delete that. And I'm going to zoom in on this. Because we're really interested in the unit circle. This is x, this is y. It asks us to find coordinates of quadrant angles. This is when the terminal side falls on an axis, either the x or the y axis. So here is my initial side. This would be a quadrant angle. Do you see that's lying on the axis? What's the coordinate of this point here? Pause the video. You know what it is. The radius is 1. To get to that point, I need to go over 0 and up 1. Okay. So what if I go to the next quadrant angle? I come over here. What is the coordinates of this angle, or this point? Now I'm going left, negative 1, and up 0. This one, I'm going over 0 and down 1. And this one is to the right 1 and up 0. This is going to become really important when I'm finding sine, cosine, and tangent of 90 degrees. Hopefully you remember sine of an angle is y over r. Cosine of an angle is x over r. Tangent of an angle is y over x. You might remember it up above we had this little triangle. With these, you'll notice there are no triangles. No matter what the angle, there's no triangles. So we have to rely on these definitions and cannot rely on our triangle definitions. So let's take a look at sine of 90. at 90 degrees, we're right here, what is y over r? Hopefully you're thinking your y coordinate is 1, and my radius here is also 1. So sine of 90 is 1 over 1, or just 1. Cosine of 90 then is x over r. So my x value is 0, my radius is 1. So I get 0 over 1, which is 0. Tangent then is y over x. My y value is 1. My x value is 0. Go ahead and type it in if you need to, but what's 1 divided by 0? It's undefined. So sometimes we will get undefined as an answer as a ratio. Let's take a look at sine of 180. We're over here now. My y value is 0. My radius is still 1. Cosine of 180 though, my x value is negative 1. My radius is 0. Sorry, my radius is 1. So I get negative 1. I'd encourage you to pause the video and fill out the rest of this table. Tangent of 180 is y over x, 0 over negative 1, 0. Sine of 270, we're down here now. My y value is negative 1, my radius is 1, my x value is 0. So sine y over r, going to be negative 1 over 1. Cosine, my x is 0 over 1, 0. Tangent y over x, I have negative 1 over 0, undefined. Sine of 360, we're back here. We're going to look at my y value, 0 over r, which is still 1. X is 1. Here we go. Sine of y over r, so 0 over 1, 0. X over r is 1 over 1. And y over x, 0 over 1 is 0. And so we see that these definitions work even when I don't have a triangle. We just have to rely on the coordinates x, y, and r. Remember, for quadrant angles, it's going to be a little different. We're going to draw a unit circle and use 1 as the radius and look at my x and y coordinates. You'll notice that for most of these, actually all of these, let me say this more clearly. For sine and cosine, the 1 in the bottom didn't change anything. And so that's why we chose the unit circle. You could have actually chosen a different circle, but then that radius becomes more important. So when I'm working on the unit circle, maybe I'll just write this down here. If r equals 1, then sine is just the y coordinate. Cosine is just the x coordinate. And actually tangent doesn't change anything. It's just y over x. All right. That is the last